bounty of some sort. Last year in Tokyo, they also had another one where the commercial organisations flew you to Tokyo and then you tried to hack the TVs, Internet of Things, and there was a lot of money made. So, on a side note. Hopefully, I won't be too boring for you. My name's Warren, I work for APNIC. What I'm giving you is a little introduction to some network security using packet tracing tools that you can do quite easily and script that. How many people are network operators? I've got 3. Well, this may not be a very popular talk after all. So what I hope to do is to give you an introduction to some tools that will help with securing your network. Let's move it forward. I might need a lesson. Which one is it? Just a bit of a technical hitch. So if you do want to try out some of these techniques I'm going to talk about, we actually have a virtual environment available for you on one of our websites that you can actually log into and create an account. So that is the academy.apnic.net website, and you can go ahead and follow this as well. It's an actual self-paced tutorial that you can go through. So what I hope to go through today is basically give you an introduction to some of the frameworks about why you need security. I'll talk about some tools that go with security, and they're going to be free open source tools. Then I'm going to show you the hard way, using command line tools to be able to look up and have a look at packet captures that you may have on your network and why you would want to do that, just to improve your security in your network. To give you an example of why you want to be more aware of what's happening on your network, at one of the workshops that we do for APNIC is we do a network security workshop. As part of that, we get you to deploy what's called a honeypot. And that just sits on your network waiting for people to connect to it. If someone's connecting to it, then that's a problem. We deployed 7 to a cloud service provider, and in 1 week, this is how many attacks we had on those 7 devices. So in the first 24 hours, we had 21,000 different attempts of SSH logins on those devices. This is a public resource on a cloud environment. One machine, or one of the honeypots, over the total period received 8,000 attacks. So that's a bit of an issue. Do you know how many people are trying to remote access your network devices? How many of you use SSH to remotely administer your network devices? Do you access your network remotely? If you run a Microsoft environment, you've probably heard of remote desktop protocol. So from a remote desktop protocol, that is the latest attack vector that's happening a lot, especially with some of the tools that have been released. So last year, Sophos did an experiment. They deployed a whole heap of sensors in different cloud providers around the globe to see how long it would take for someone to try and attempt to break into those remote desktops. So this example here, you may not be able to see it up the back there, but the longest it took after they deployed it, or the shortest time, sorry, was 1 minute and 30 seconds. Within 1 minute and 30 seconds, after freshly deploying these machines, someone had attempted to get into it. That happened in Paris. The longest it took before something attempted was 15.5 hours. So when you think about some of the services that you are deploying, do you think about how do you update it? Do you plug it straight into the network and connect it to the internet? That means you're exposing your systems. So there are problems with that. Throughout the globe, there are different legal requirements for you to protect your resources. And they're just some resources there that reference that. So one of the more famous ones is the GDPR. In Australia, where I come from, we have this notifiable data breach law that came into effect as well. And there's other laws that are coming into effect throughout the region as well. So when you start thinking about your network, you think of it as an engineer. What steps you need to do to be able to build out your network and secure it. So you connect it and you update it and so on. That same process happens from an attack point of view. So there are different concepts about how people are going to try and get into your network. And so they put it into different categories. And this one is one example of a life cycle from an attacker's point of view. So what's going to happen is I need to find out about your network. So that's an initial recon. Once I've got that, and this is where the bug bounty program would come in handy, is that I look for vulnerabilities in those systems once I know what sort of systems you're running. If there is a vulnerability, that gives me your initial compromise. Once I've got that compromise, I'm going to then try and maintain my access to your system. So I'm going to establish a foothold, and I'm then going to go through and try and get to different parts of your systems and your network until I finally get what I want. Okay? So that's one attack framework. In Australia, we have the cyber security platform. The government tries to promote security in a positive way, and it talks about some strategies to help against those attack frameworks. In this case here, it mentions about monitoring and using intrusion detection systems. So making sure that you can tell when someone's trying to get into your system. Think about your house, your home security. You put windows and doors and locks on your house. If it's very important, you may have a security or building alarm system. That building alarm system is like an incident detection tool. It's going to let you know when something's happening that shouldn't be happening on your network. In America, there's the NIST, and they've got a publication as well. And in here, they've got different mitigation frameworks that you can use. They've got identity, protect, detect, respond, and recover. So if you think about doing packet analysis, that's helping with the detection phase of your discovery and network security. So what we're looking at here is being able to drill down, and that makes recommendations on what you should be doing when you're doing the detection. And that's having this baseline of your network operations. What is normal traffic on your network? If you don't know what normal traffic is, how do you know that it's bad traffic? How do you know that it's good traffic? Is it normal that this particular machine should be copying all the files from the file server up into some sort of cloud environment? You don't know that. So you need to make sure you have a baseline of what is good traffic. What is your normal business traffic? Once you've got that, you can then start looking for strange activity. If you want to get very technical, there are different standards and different types of activities that you can do, if you want to go back to this slide. Now, it's a bit small to access this, but if you've got access to a web browser, if you can go to attack.mitre, mitre.org, great resource if you're not familiar with cybersecurity at all. This resource is basically a hyperlinked web page, and it's a framework that tries to go through the different stages of an attack. Each of those hyperlinks will then take you to a page and tell you how to do that attack, and then some of the mitigations around that. This is a public resource to try and help identify techniques that can be used against you or against organisations, and then as a community, how do you stop that? So if I drill down on that, you might be able to see it a little bit better up the back, but what we've got across the top is the different mechanisms of getting into the network, or those attack phrases. So the first one was initial access. Down the column is the actual technique that is going to be used for that. So for example, drive-by compromise. How many of you surf the internet? How many of you use the internet? Yeah? How many of you visit a web page? So a drive-by compromise is where your browser goes to a web page and there is a script on there. Now that's going to, when you connect to a web page on the internet, you're telling that web server what sort of computer you have, what browser you're using, what operating system do you have. So based on that, that JavaScript or the script that is on that website can make you download some software specifically for your system to help compromise that. So you can then click on that hyperlink and it will tell you what technique is going to be used and some suggestions on how you can minimise the risk. So that's a good resource if you're not familiar with cybersecurity. From a network operator, what can you do? We look after network traffic, true? So as part of that, there are tools out there, intrusion detection systems, intrusion prevention systems, that you can buy off vendors, or you can get open source versions of that. Anyone heard of Wireshark? Yeah? So if you've used Wireshark, you're doing packet capturing, you're doing packet analysis. As part of that though, when you do your packet analysis, you're going to try and figure out what is your normal traffic and what is not normal. And you're going to be looking for specific marks in your packet. So when I say that you connect to a website, you're connecting to an IP address. Yes? That IP address could be an indicator that it's a bad site, or that website address could be an indicator. So you're looking for distinctive marks. If you've used antivirus program, that's similar to what this is doing. It's looking for a signature, something that it knows is bad, based on certain indicators, certain marks of that. So you have IP address, host names, and there's this one here, especially from a hacker point of view, you want to get recognition or get a reputation, so they might put ego strings, meaning saying who their name is, or saying thank you to someone out in the community. So what we're going to do is then you're going to use some sort of intrusion detection system to determine this is bad traffic, let's do something about it. There is a tool out there called Nmap, which is a network scanning tool. So I can connect to a network and tell it to go scan the whole network and tell me what machines are on the network. And depending on what type of scan I do, I can also ask, tell me what ports are open, what operating system it is, and are there any vulnerabilities on that. So as a network operator, if I'm running an enterprise network, I could easily put this into my intrusion detection system to determine looking for certain strings in there. So in this case here, I'm looking for the keyword Nmap to hopefully get an alert system pop up and say, warning, Someone's doing a scan of your network. Now, the problem with that, from a packet analysis point of view, nowadays, a lot of traffic is going to be encrypted. True? So that means I'm not going to be able to see as much information in that because it's encrypted, unless I am able to unencrypt that. So that's where session analysis comes in. I mentioned a few minutes ago about what is normal traffic on your network. Is it normal that a computer is copying all the files off your file server and sending them up to the cloud provider or up to a cloud service? No. So based on that session, it's unusual traffic. So I could use that as an indicator. So what I'm doing is looking at the characteristics of the action that the computer is doing or the user is doing at that point in time. Is your business 24 hours a day, 7 days a week? If it's not 24 hours a day, 7 days a week, is it normal that your computers are copying files at midnight up to the cloud? The other thing is, as network operators, we expect protocols to act like protocols. True? How many of you use ping to test connectivity? Did you know that you can use ping to transfer files? How many of you use DNS? I've asked you how many of you surf the internet. So if everyone here surfs the internet, you've used DNS, which is domain name services. I can use domain name services to send more information than just a domain lookup. I can use it to transfer files. So that is looking at what I know is good traffic and what is bad traffic. So knowing what is normal in your network. So is it normal to be able to transfer files using DNS? No. You would not want to allow that traffic. Recently, an ISP in the Pacific had that issue where on the mobile phone, how many are ISPs here? How do you make money? You make money by billing your customers. True? How do you bill your customers? You see how much data they're transferring. Yeah? You see what time they're there. Do you monitor DNS? And do you charge them for DNS traffic? No. This Pacific provider, this internet service provider in the Pacific, discovered that people had found a way to use DNS to surf the internet. They lost thousands of dollars because they only have a limited uplink capability because they're in the Pacific Ocean. They pay lots of money for their data, and so this ISP was not making money from their customers because it was a small community, so this person knew how to do it, so they then told their friend, they then told their friend, and so they had issues there. On this slide is an example of using DNS in a way that it wasn't designed. So what it's doing is it's basically compromised a computer system. I'm encrypting with the base 64, the IP address, the host name, the username, and the session or the system UUID, and then I'm just attaching that to a DNS query to badsite.com. So I just set up a DNS server on the internet listening for this traffic, and now I get all that traffic coming to me with that information about the compromised site. If you have a look at the query string, that's quite long. It's very long indeed. So what you could do, for those people who've used Wireshark, I could do a DNS query name length and check that if it's greater than this length, tell me about it, and I go and investigate it. So a session is looking at the unusual behaviour of the whole session. The signature is going to be looking at what it knows is bad. So which one do you use? You would use both. So you use your intrusion detection system to be able to alert you, and then you go and investigate further. Some open source tools that you could use for that, so you don't have to go purchase or spend your budget on this. At the top, you've got your database and some tools that help sort out the information that you keep. You've got your intrusion detection system, Snort and Sierra. And then you've got some automation and analytic tools to help with deciding if it's good or bad traffic. And then at the bottom, you've got your command line tool, TCP Dump, and there's also Wireshark and things like that. Each slide goes through and gives you a little bit more detail about that, but I don't want to keep you going because this is supposed to be a 30-minute session, so you can read that in your own time. One resource I should tell you about is Cloudshark. How many of you used Wireshark? Yeah? Cloudshark is a web-based version of that. Only thing I would suggest though is if you're going to upload your packet captures, make sure you've sanitized them so you're not letting out information because they're publicly available. But from your point of view, if you want to look for someone else's packet captures or see certain traffic, you could use Cloudshark for that. I mentioned that everything I'm about to show you, you can do it on our virtual environment, or you can download and install a tool which I'll tell you about at the end of the presentation. So if you go to this website here, academy.apnic.net, there is a virtual lab environment, and in particular I talk about the signature and session analysis lab. So what I'm going to talk about now is I'm going old school. I've been working, I did my first programming course in 1983, so I've been around for a little while. So I like the command line. I like to script things. And as network operators, you probably do that. You like the console. So that's what I'm focusing on at the moment. So how many of you have used TCP Dump to capture packets? Yeah? If you're a hardcore network operator, you'd know how to do that. So TCP Dump can do a lot more than just capturing packet captures. You may not know that, and I'll show you a couple of techniques in this quick presentation. So some commands. If you go to that Academy website, we're using a tool called Security Onion, and I'll talk about that later on. Security Onion gives you some sample packet captures. So any sort of packet capture, if you've got one here, you can use that. These commands will work. So what you do is you use the TCP dump command, and we're just going to tell it not to do the DNS lookup to make it run a little bit quicker, and we're replaying our packet capture file. So whatever the name of your packet capture file is, and then we're going to do something with it. So the first line there with the WC-L is saying do a word count on how many lines. That tells me how many packets are in that packet capture. Then I'm going to have a look at the top 10 records in that packet capture, just to make sure it's not corrupt. It's always a good idea to do that because you can get corruption happen. Now, usually I'll show you a video next of these commands, but what are we interested in when we start looking at packet captures? We're looking for bad, unusual traffic. So you might want to be looking for things like source address, destination address. So the next few commands, what I'm doing here is I'm saying go to the third field, in this case is the source address, and cut that out and show me the top 10 records. So all I'm now doing is focusing on the source address field. It gives me the source address and the port of that machine. What could I use that for? Well, port number could be an indicator of a command and control. So you can maybe do something with that. Source address. you might be able to do something like finding out the top 10 source address. So people using YouTube on your network, or BitTorrent, or something like that, peer-to-peer. What I'm doing here is drilling down on that again. So I'm saying focusing only on TCP or UDP traffic, getting the source address. Now that source address returns the port as well. I may not be interested in the port, so I'm now cutting off the port number and just returning top 10 records. This one here is going to then sort it based on uniqueness, and then I can get my top 10 destination addresses plus how many packets. So if that was a packet capture that went for 30 minutes and 90% of the traffic was going to one address, that could be a bit of a problem. I talked about DNS. In this packet capture, whenever you surf the internet, you're taking a domain name and you're converting it into an IP address. So the first slide shows you how to drill down on an IP address. This slide shows you how to drill down on which domain names are in that packet capture. If you find a malicious or a suspicious domain name, example might be, not picking on a particular economy, .ru. In Australia, .ru is usually an unusual website to go to. So we tend to focus on those. If you do find an unusual, or it could be badsite.com as the URL, what I could do is then go to this web address here. How many of you used VirusTotal in the past? No? So VirusTotal allows you to submit files that you think are suspicious. It allows you to submit URLs that you think are suspicious. Now, because it's a global database, someone else may have already submitted it. And if someone else has submitted it, it usually means that someone's investigated whether it's safe or not. If you get a result back saying it's unsafe, then you're definitely sure that it's unsafe. Because I'm not an expert just looking at that. So I rely on the community. So just to show you some of these commands in action, hopefully you can see this. I did test it on a different projector, so it's probably not going to be too good here. So what I'm doing is just running through those same commands as before. I'm doing the TCP dump, and I'm going through and I'm just going to have a look at the top 10 records or do a word count. So there's 1,771 packets, and we get an output similar to that. So if you looked at Wireshark in the past, it will be very similar to that. So now I'm focusing on just getting the results of the IP addresses. So we've gone from all that information up the top just to the IP address and port number. From the IP address and port number, I can then drill down on that even further. I should have played it quicker than that, shouldn't I? So I'm now drilling down just on the IP address, and then I can go through and find more details. So now I'm just going to sort it so that way you can see what it looks like there. Now I'm not too sure, will these slides be available for download? Oh, there's no one here. Maybe next time. If you do want those, you're welcome to contact me. I can give you the video of this. So all I'm doing here is doing a unique sort, and then I'm just going to send that down, and it shows me the packet capture. So the top address has 922, so that's more than 50% of the traffic is going to that address. Just going to move on because we're going to run out of time. So that was just doing one-line commands using the TCP dump. And I'm only looking at one packet capture. Now that's fairly cumbersome, isn't it? Time consuming. How many packet captures have you done? You might have hundreds. An example of a security audit, you might set up a timed packet capture. So throughout a period of, say, 5 days, you would, at a random time throughout the day, do, say, 7 or 8 packet captures and store those into a directory. So what I can do is then use TCP dump to then automate looking at those files for specific tasks. So in this case here, I'm using a bit of scripting to basically say, have a look at in a directory, in this case, for anything that has the extension PCAP. And then loop over those, and I'm going through and I'm looking for anything that has something to do with port 53, and I pull out the domain names in that packet capture. So now I've gone from doing one line command per packet capture, I'm looking at every packet capture in a directory for a domain name. Okay? That's okay. There's still some manual processes. There are other tools that you can use to then send that off to VirusTotal using an API. So you then don't need to touch it at all, and you get a nice little report at the end of your security audit saying these websites are dangerous for you to investigate further, and they were visited by these workstations. The other thing you can do is you can, how many of you are network operators and absolutely sure that no one is sending plain text passwords over your network are dangerous for you to investigate further. You'll be surprised how many plain text passwords are sent across your network today. How many of you are, you'll be very surprised. So doing that same thing, doing some random packet captures over a period of time, you can do the same sort of concept of passing through those packet captures, and I'm looking now for all sorts of traffic that are doing that unencrypted. It's a bit harder to find it if it's encrypted traffic, but I'm looking for HTTP, sort of file transfer protocol, email like SMTP, IMAP, PAN3, and telnet traffic. Then I'm looking for keywords that you would expect to see, like login, user, password, all these different values I'm looking for. And what that will do is hopefully you'll see no results in your network. But if you do see results, you then need to investigate further and look at a process of securing that communication so that way you're not sending plain text passwords over your network. Okay? So this is a manual way of doing things. There are tools that I mentioned previously that are free and open source tools that will help with this. If you are interested in experimenting and learning more, there is a Linux distribution that you can download as a virtual machine, or if you've installed Ubuntu in the past, it's a similar process of installing, called Security Onion. That lab environment that you, if you wanted to go do this later, is running Security Onion. What that does, the Security Onion, it basically sets up all of those tools I've mentioned previously in one nice machine layout. It uses Docker to run most of the tools, but there are some tools that you can then segment or separate and have multiple occurrences of them. For example, your sensors for detecting network traffic. You might need more than one sensor. You can also then have your logs separated out. You might have different collection points for your logs, and then they get filtered into the Docker container, and you get access to it that way. If you are interested in learning more about using Security Onion, if you go to that virtual environment, you're welcome to do that. There is a step-by-step guide on how to go through and complete some of those tasks, and actually using some of the graphical user interface tools to do similar analysis of what's called malicious or dangerous traffic. Any questions?
Any question, please? Any question?
I don't buy it.
No question? Thank you so much, Mr. Ram. So, now, break time.
Am I early or
Break
late?
time.
I wasn't too. Oh, 7 minutes earlier. I've got 7 more minutes. I can keep
Yeah,
going.
you can talk whatever you like.
I can show you the website. So I mentioned at the start of the talk about the attack framework. So if we go to the attack.martyr.org, go to the getting started, it's got different ways of using it, and there's a couple of videos that talk about it. Where's my mouse? And I want to go to the matrix, and then in the matrix I can just click on the tool or the compromise. Oh, split screen. Thank you for telling me. Oh, that makes it easier. I can log in and do other things. So if you go to this website, attack.martyr.org, click on the matrix, and then you can now click on the different techniques and you can read more about those. This drive-by compromise, it actually happened against Australian Parliament, the government, last year. One of the politicians was browsing the internet while they were at the government building, and they got compromised, which then caused an attack on the internal government website. So what you have here is the touchpad's not as sensitive. So it goes through and talks about what it is and how it can happen. Typically, this is what happens. Why is it done that? And then sometimes they will identify certain attack or malicious groups and say this is how this group is going to try and get into your network. So here they're talking about those different groups that are known attackers that will try and attack your system. So there's quite a few organisations, or just like how you work for a large organisation or enterprise, because being a malicious actor is very profitable, more and more people are actually moving towards creating large organisations just to compromise your or compromise large organisations' websites to make money. An example was the Amazon attack. They think they netted $20 million or something, so that's pretty good. So that talks about the threat, and then down there you've got your mitigations of what you can do, making sure your software is up to date. How many people updated their software today? Microsoft's Patch Tuesday happened. How many of you use Microsoft Windows? No one. So, updated this morning or yesterday? Yeah, because there was 50 vulnerabilities patched this week for that. Major update. Of course, script32.dll has got a major flaw in it which affects all your logins. So, I was going to go to a different website, but someone else is logged in, so I won't do that. But the other website that you can have a look at, and this is the one with the virtual labs, academy.apnic.net, and I actually have a lab there that you can do. I think later in the year I'll be doing a live webinar, so if you have any questions you can always go to that as well. Any questions? Obviously not, because I used up my time more. Hope you enjoyed it.